Last time, we talked about Newton's first law of motion. In today's episode, we're going to talk about his second law. Newton's second law of motion states that the acceleration and net forces acting on an object are directly proportional. This means that the more force applied to an object, the faster it will accelerate. The law also says that the acceleration is inversely proportional to the mass. And this means that the more mass an object has, the slower it will accelerate with the same amount of force. We already kind of understand this concept intuitively. We all know by intuition that a heavier object requires more force to get it moving. But since this is science, let's not just trust our intuition. Let's see if we could actually demonstrate this in real life. Here, I have a juice box trolley, and I've placed 12 coins in it. It's connected to a binder clip with a piece of string, and I'm going to hang the clip over the edge of my desk. The clip has some weight, which will pull onto the trolley, and the force of this pull should cause the trolley to accelerate forward. Okay, I guess the force wasn't enough to get it moving, and we have another problem. The edge of the desk might be providing too much friction. To reduce friction, I made a simple pulley mechanism out of cardboard and some plastic straws. The idea is to attach it to the edge of the desk and have the string slide over the plastic tubes. It's not as effective as a real pulley, but it should help a little bit. Let's add some extra weight and see if that works. Great! It traveled 32 centimeters in 1.33 seconds. That's an acceleration of 0.361 meters per second squared. Let's add another coin. It covered the same distance in 0.92 seconds. An acceleration of 0.756 meters per second squared. Let's increase the force one more time. 3 coins. This time, it covered the same distance in only 0.79 seconds, an acceleration of 1.025 meters per second squared. So increasing the force clearly increases the acceleration. Now, instead of increasing the force that pulls on the trolley, let's increase the mass of the trolley. Let's double the mass by adding 12 more coins. It traveled the same distance as before in about 1 second. That's an acceleration of 0.64 meters per second squared. And if we added 12 more, we get an acceleration of 0.284 meters per second squared. If you look at the numbers carefully, you'll notice that the numbers are almost the same, just in reverse. The slight differences in the results are mainly due to the primitive instruments I'm using. But that doesn't really matter because we already proved the point. The more force applied to an object, the faster it will accelerate. And the more mass an object has, the slower it will accelerate. If you'd like to make your own trolley, to do this demonstration at home or in a classroom, you can follow these simple instructions. You'll need a juice box, an arc knife, 4 bottle caps, some string, a plastic straw, a bamboo skewer, a binder clip, some coins, and a small resealable bag. First, Cut an X across one of the sides of the box with an art knife. With the box now opened, wash the inside and remove any leftover drink. Then, cut off the flaps with scissors. After that, make a small cut in the center of the top of the box. Next, we're going to cut the straw to the width of the box. This can actually be any width, but I prefer to make it slightly wider than the box. Attach the straws to the box with some hot glue. Next, cut the bamboo skewer a little longer than the straw. You'll need to make sure that the bottle caps won't rub against the sides of the box. Then, carefully puncture the center of each bottle cap. After that, use a pencil to increase the size of the hole. Now you can attach the bottle caps to the bamboo skewers. If you want it to be more durable, you can glue the bottle caps to the skewers with hot glue. Use a pencil to increase the size of the small cut we made at the beginning. Put the string through it and tie a knot around a piece of leftover skewer. Finally, cut the string to your desired length and tie it to the binder clip. And there you go. As always, if you enjoyed today's video, please remember to like, share, subscribe if you haven't already, and ring that notification bell. That's it for our lesson today. Catch you later.